All right, so in this lesson, we are answering the question about the tangent line. So it's a tangent line problem, okay? Basically, what we want to figure out is the slope, right? The slope of a line always indicates the rate at which a line rises or falls. So if we take a look at this first picture over here, I know at the bottom of this, looks like a parabola, that the slope is going to be 0 because there's no change. This little blue line as we read graphs from left to right, I know that this is negative slope, and that looks kind of steep for a negative slope. And then this little red line right here, our slope is greater than 1, so it's a positive kind of slope. So anytime, right, our lines, these three lines, touch just one single point on our graph, we're going to call that the tangent line. Okay, and what's really important is we should write this down. The tangent, why is that so big? Let's write it down a little bit smaller. So we're going to say this. The tangent line to a graph, or to the graph, is the line that best approximates the slope of the graph at that point. Now, you might be thinking to yourself, well, how in the heck are we going to find the slope of a graph at just one single point? Don't, when we look at a line, we need 2 points in order to create a slope. That's what we've always known, right? We've always dealt with slope is always the change in y over the change in x, or aka y2 minus y1 over x2 minus x1. So now what I'm saying is we're going to find the slope of a line just using 1 point, right? That's going to be a little challenging. Okay, and I want to make sure that we understand the difference between a tangent line and just any old line, right? So if I take a look at this picture right here, okay, we got a tangent line at this point right here because it's where this little blue line is crossing this graph, so we're finding the tangent of this line, right? Not a tangent point over here. But I do notice that this is a second point, and what we're going to do is we're going to try to get this second point closer and closer and closer to this original point, okay? And basically what we're finding is we're finding the secant line, okay? So here, let's take a look at this first graph on this page right here. So again, tangent line, right, is where it crosses at 1 point. Secant line is where it crosses at 2 points, okay? So again, tangent, if I wanted to find it, of this point right here, and then secant would be as our 2 points. So what's basically happening, if animation actually worked on my computer, okay, this second point right here is going to move closer and closer and closer, right, to this point right here, right? We're going to approach it, but we're not going to get to that point, okay? So again, if we call one of those points x, and again, f of x, if we add some sort of distance to our height value, okay, and so this new point will be x plus whatever h is, which means this will be f of x plus whatever h is, okay? And what's going to happen is this point's just going to keep moving closer and closer and closer, and it's going to get so close, right? It's going to get so close that eventually it's going to seem like the tangent line, okay? So I want us to write this down, okay? It's called the definition of the slope of a graph, okay? So what we're going to say is, this. We're going to say that the slope m of the graph of f at the point x comma f of x, right, is equal to the slope of its tangent line at the same point, x comma f of x. And we can write this, and is given by this point. So we're going to say m is really the limit as, oops, not x, sorry, as h approaches 0. M is our secant line, okay? Because again, if we take a look at this, if h is 4, and then 3, and then 2, and then 1, as it gets closer and closer to 0, it's going to turn out to be our tangent line, okay? And so if you think about this, right, these are my first point. So this is like x1, y1, and this is like x2, y2, okay? And so what we're basically saying is, if we remember what slope is the change in y over the change in x, or aka y2 minus y1 over x2 minus x1. Again, as my h is getting closer and closer to 0, aka the limit, right? It's approaching it, but again, if it's 0, we then can't find our slope. What we're going to do is we're going to take these points and we're going to subtract them from each other. So how we're actually going to write that is we get to say this. So instead of just writing it out like this, we're going to say the limit as h approaches 0 of f of x plus h minus f of x, right? And then this is just going to be h on the bottom, okay? Because if you think about it, right, the reason why we don't want to add anything else to this is because we would say our x2, x plus h, minus our x1, x, right? So essentially it would be x plus h minus x. So these two things are going to cancel and we'll just be left with h. Okay? And we should write this down. We should say provided this limit exists, right? So hopefully our limit does exist, because if you think about it right now, if I plug a 0 in for h, I'm going to get f of, so if I plug in a 0, I'm going to get x plus 0 minus f of x, and then all over 0. This is just f of x. So f of x minus f of x, this just becomes 0 over 0. And all of a sudden, we're back to that indeterminate form, okay? So what we want to do is we want to try to figure out how do we find a point, and how are we going to use this information, okay? So let's jump into our very first problem, okay? So example number 1, we're going to say this. Find the slope of f of x is equal to x squared at the point -2, 4. Okay, now if we were to graph this, right, this is a parabola, right? So obviously it'd be 0, 0. If I plug in a 1, I'm going to get a 1. If I plug a 2, I'm going to get 4. So 2, 3, 4. So right there, -1 gives me 1. And then 2 will give me 4. So again, here's my lovely looking parabola. So what we want to do is we want to find the tangent of this point right here. Okay, so we want to figure out what is that tangent line to that point. So again, looking at this, it seems like my slope should be negative. Okay, because my graph is going down. Okay, kind of takes us back to our first point right here. So let's pretend that that point is -2, 4. Okay, so we're going to use this idea of this lovely formula to try to figure out what we're going to do. So let's remember that our m secant line, right, is f of x plus h minus f of x all over h. This is my x, this is my y. So we're going to plug in what we have, right, as our limit, right? So m is our limit. So I'm going to plug in. So I'm going to say f of -2 plus h minus f of -2 all over h. Again, this is the limit as h approaches 0. Okay, so again, I can't plug a 0 in because then these two will cancel away, leaving me with 0 over 0. So what I want to do is I'm going to take it over here, and I'm going to figure out what is -2 plus h. So what happens when I plug in over here? So f of -2 plus h, so -2 plus h squared, so -2 plus h times negative 2 plus h. So that will give me a 4, negative 2, so minus 4h plus h squared. Wonderful. So come back over here. So I'm going to say the limit as h approaches 0 of 4 minus, 4h. Get it back to blue. So 4h, and then plus h squared, and then minus, so let's do again f of negative 2. So this will just be negative 2, 4. Well, we already had the answer right here. So this will be, so this is my first value, minus my 4, right? All over h, okay? Nothing really needs to be distributed. So we're just going to say 4 minus 4h plus h squared minus 4 all over h. The 4 and the 4 cancels away, leaving you with the limit as h approaches 0 of negative 4h plus h squared all over h. h's can be simplified. So this is the limit as h approaches 0. And then minus 4, this goes away, so plus h. So now I can plug in the 0 in for h. So negative 4 plus 0. So here's my slope. So the slope of this graph at this point should be negative 4. And that makes sense. It looks pretty steep, right? It's supposed to be negative. If we found it over here, definitely we'd get a positive value. Okay, and that's all we're doing. Okay, so why don't you try number 2 by pausing the video. So again, find the slope of f of x is equal to x cubed at this point. So 2 comma 8. So pause the video, see what happens, and then we can continue. Okay, so if you're coming back from pause video, right, the secant, right, is going to be the limit as h approaches 0. So this will be f of 2 plus h, and then minus f of 2 all over h, right? So this time we have to figure out what is 2 plus h when I plug it in to here, cubed. So 2 plus h times 2 plus h times 2 plus h. So this will be a 4 plus 4h plus h squared, very similar to the last one. And then when I multiply this out, so this will be 8 plus 4h plus 8h plus 4h squared plus 2h squared plus h cubed. Awesome. And I'll simplify it later. And then f of 2, we already know, is 8. So that's easy. All right, so limit as h approaches 0 of, so this will just be 8, combine my values, so these and these, so 12h, and then plus 4 and 2, so 6h squared plus h cubed, again minus 8 all over h. Are you noticing that whatever's in the second part is going to go away from the first part? So this is just going to be the limit as h approaches 0 of just 12h plus 6h squared plus h cubed, right, all over h. The h's go away, so limit as h approaches 0. So this will just be 12 plus 6h plus h squared. So when I plug in a 0 now for this problem, 12 plus 0, this answer will just be 12. Okay, so in the next video, what happens if I want to find a formula? I don't want to just have to keep finding points, because what happens if I wanted to find the slope of multiple points on this? So what happens if I wanted to find the point 1, 1, right? Do I want to go through this whole process? Or can I come up with a formula that's going to work a little better for me? So that's what we're going to talk about in part 2.